Okay, as we begin the second part of the notes here, I'm going to start with example 6. And the key, pay attention, the key to example 6 is the inequality that has an unusual solution set. So there's two that we're going to cover. In the first one, they're going to give us this equation. They're giving us the equation where we have 2 parentheses x plus 4 is greater than 2x plus 3. So let's go ahead and solve for this one. So step 1 is obviously distribute the 2. So you end up with 2x plus 8 is greater than 2x plus 3. Always remember, when you're working with inequalities, if you multiply or divide by a negative number, reverse the inequality, right? Just a reminder. Do you notice here that when I subtract the 2x on both sides, I end up with an answer which is basically 8 is greater than 3? That's not untrue. And so this is true. Because this is true, this is all real numbers when we look at the solution set. So our number line, we will go from negative infinity to positive infinity, and we would argue that x is any value within the number system. So we would say x, in sub-builder notation, we would say x is a value where x is a real number. Or you can actually, I'm going to put Rn for real number. Or you can say, in interval notation, negative infinity comma positive infinity. So that's one unusual solution they cover. The second unusual question is this one, where I have x plus 7 is less than or equal to x minus 2. And so again, if I subtract the x's, notice that my next line is 7 is less than or equal to negative 2. This is a false solution, or false, so we will call this a null set or no solution. And so we would say the inequality 7 less than or equal to negative 2 is false for all values of x. And because it is equivalent to the original inequality has no solution. Hence, null set, so no solution. Okay, so let me give you one example to try of both. So I'll write this down here and then pause and then give you the answers. So if you're watching this at home, go ahead and you want to pause the video after I give you the questions, and then I'll give you the solutions shortly following. So to consider this example C, and let's consider this example D. Okay, so go ahead, pause the video. And here's the solution for this. So the solution for part C is basically negative infinity comma positive infinity. And in this case, null set. Your final answer here will be 3 is greater than 2. And over here, you're going to experience where 1 is less than or equal to negative 1 as a final answer. Okay, example 7. In example 7, we're solving a compound inequality. Compound inequality. And that's the main idea for this one. So in this one, they're going to start you with negative 3 is less than 2x plus 1, less than or equal to 3. And so if we begin to solve, notice that this is almost like an absolute value where you have an x in the middle, except it isn't an absolute value. This is not. So step 1 is we're going to subtract the 1 in all 3 sides of the inequality. And now you're left with negative 4 is less than 2x is less than or equal to 2. Obviously, the next step is to divide by 2 since we're solving for x. So this gives us negative 2 is less than x is less than or equal to 1. And so in an example such as this, if we look at interval notation, in interval notation, we're going to have the -2 not inclusive, 1 inclusive, because that has the equal to sign. Okay, so I keep saying inclusive, not inclusive. Remember, equal to sign means use the bracket. Awesome. Set builder notation. I'm going to separate these just to make sure that you're understanding the language, because that's what you're really grasping here. Where x is in the set of values where x is greater than -2 and x is less than or equal to 1. So if you notice, I always read from the x out, even though it looks different. So I'm reading x is greater than -2, but x is less than or equal to 1. That's what I'm suggesting here. Given that information, we're now going to draw it on the number line. So here's -2, here's 1. Positive infinity, negative infinity, that's just a visual. -2 is not equal to or not inclusive, so draw your parentheses, and here's your bracket for the 1, because that is inclusive. And we are shading everything in here. So let me go ahead and give you a try question of this type. You can pause the video. So we're going to solve and graph. And when I say solve, I mean give me the interval and set notation for this and graph it. So they're giving us 1 is less than or equal to 2x plus 3. Less than 11. So if you're doing this at home or in the classroom, we're going to just pause the video for a few minutes, and here's your solution. The solution for this one should be in set builder notation, where x is in a set of values where x is greater than or equal to -1 but less than 4. In interval notation, we're going to write where this is -1, 4 with a parenthesis. So if you draw the number line again, just think of x as the numbers that are in between these. So here's -1, 4. This is not inclusive. This is inclusive. And we're shading everything in between. So there's all the x values are sitting in there, in that region. Okay, so what happens when we have an absolute value inequality? Now we're heading into example 8. So I want you to remember in this case where if I have, for example, the absolute value of u is less than some number, that means that these numbers are notated as such where c is the value, so u is greater than or equal to u is greater than -c or u is less than c. Same thing applies if I have the absolute value of u is greater than c. So in this case, we would say u is less than -c or u is greater than c. And of course, we still have the equal to, not equal to, so these are relative whether they are or aren't included in the original question. Just keep that in mind. You have to be careful when you interpret this, because the equal to may actually violate one part of the solution and you may not be able to use it. Let's look at an example. So these are absolute value inequalities. All right, so in absolute value inequalities, they're going to start you with the absolute value of x minus 4 less than 3. Now, you do remember that I said to you, one of the things that we always try to do when we solve, there's a positive side and a negative side. So what we would want to do is, let's satisfy this over here as negative 3, and we're going to subtract the 4, actually in this case add the 4 to both all 3 sides of this equation. And so that leaves us with 1 is less than x and less than 7. So if I'm looking at this is actually pretty easy, because technically when we're looking at the diagram of an inequality, we are going to look at this in set builder notation. We would say where x is in the set of values where x is greater than 1. So here's the x, it's greater than 1, but it is less than 7. In interval notation, we would then say 1 comma 7, not inclusive. And when we look at the graph, now the graph is where this gets unique. So let's take a look at an absolute value equation first. So I'm going to go out to a new tool for you. It's called Desmos. I use Desmos quite a bit. You should too. Oh. And so if you give me 1 second, let me pause this first. All right, so here we are. Let me pull up the Desmos, and in the Desmos, what I want to do is show you. You can do an absolute value equation in Desmos. So in this case, absolute value x minus 4, and I want this to be less than 3. Okay. Let's take a look at this graph. Oh, so we look at our equation, our original graph. Notice that I kept the x minus 3 out, or less than 3 out. So I'm actually going to change this to where y is equal to 3, because technically that's what is being graphed. Do you notice the points are 1 comma 3 and 7 comma 3, where it actually intercedes, where x is equal to 1. And also we have another point where x is equal to 7. So these points that you see here, I put a 3, I meant a 1, sorry. These points that you see here are the crisscross points where you have the intersection of all of these values. And so this is what we're looking at in this case, where if I'm looking at the inequality or the absolute value function y equals x minus 4, then you can see that if x minus 4 is less than 3, your values for x for the domain should be 1, 7. And so that's your solution set. So it's good you see this and make sense of it. Take it in as your own so you own it. All right. I'm going to give you a try question. I would like for you to try and draw it on your paper. So go ahead and try this one. I'll give you a moment in class, or if you're doing this at home, just follow the example I just did. If you're doing this by yourself and at home, go ahead and pause the video. I'm going to give you a solution set right now. So the solution and interval notation for this should be -3, 7. In set builder notation, you have values where x is greater than -3, or x is less than 7. And so there you go, in interval notation and in set builder notation. Looking at the graph, here's -3, here's 7. X is greater than -3 but less than 7. Neither of them are inclusive, so they're both exclusive, so they're both parentheses, and I'm basically shading in here. All right, very good. Okay, so let's look at another example, example 9. In example 9, we're solving an absolute value inequality again. So they're giving you, in this case, -2 absolute value of 3x plus 5 plus 7 is greater than or equal to 13, -13. And so remember, we are evil math people, and we like to isolate this absolute value. We want it all alone. So step 1, let's subtract that 7 on both sides. Notice this time I said both sides, because we haven't isolated yet. We don't want to have this isolated and set to its opposite yet, just yet. So this is what we're left with at this moment. Next step is we're going to divide by, on all two sides, we're going to divide by -2 on this side and this side. So this is division on both sides. We're now left with absolute value of 3x minus 5 is less than or equal to 10. Remember, you're dividing by a negative. Flip the inequality. Now that I'm isolated on a desert island all by myself, I can now do less than or equal to, in this case, to -10. Notice the inequality is always faced in the same direction, so that should make it easy for you to remember. Step 1, add the 5 to all three parts of this inequality. So you now have -5 is less than or equal to x. My bad. I went too far too quick. Give me 1 second. Let me recuperate and see. Did I write this as a minus? Oh, it's a plus. That's why. This is a plus. So that changes our ammo here. So what's going to happen is we're actually going to subtract that 5 on all three of these. So you'll have -15 is less than 3x is less than or equal to 5. Sorry about that. I missed the positive. And now we're going to divide by 3 here, here, and here. And we are now left with -5 less than or equal to x less than or equal to 5/3. And so, yes, it's kind of strange, but interval notation wise, this is just simply -5, comma 5/3 inclusive. Set builder notation, we're going to have -5 less than or equal to x less than or equal to 5/3, and obviously don't forget your front notation where x is in a set of numbers, where x is greater than or equal to -5 or x is less than or equal to 5/3. Remember, 5/3 is also the equivalent to 1 2/3, which is equivalent to 1.6 repeating. So on a number line, you're just going to estimate where that would fall. So you would basically do your number line. So here's -5. Let's assume this is 0. Let's go with 1. Let's go with 2. Let's assume this is 1.5, just to give you a visual. So I'm going to mark somewhere around 1.6 repeating. And then we're shading everything in the center. And that's your graph. All right, let me give you a try question on this part. So we have -3 absolute value of 5x minus 2 plus 20 greater than or equal to negative 19. Okay, so if you're doing this at home, pause the video one more time. In interval notation, this would be negative 11 over 5, inclusive, up to 3, inclusive. In set builder notation, you would have where x is in a set, where x is greater than or equal to negative 11 over 5, but less than or equal to 3. And again, you would graph it on the number line accordingly. Okay. Let's do the final example here, example 10. So we're solving an absolute value inequality. In this case, we have 7 less than absolute value of 5 minus 2x. And so in this case, I want you to remember that we have two situations. The other one, in this case, because this is in essence 5 minus 2x is less than negative 7, and, or in this case, 5 minus 2x is greater than 7. Those are the two conditions that we're looking at. All right, so if I solve for this, so let's solve for each respectively. If I subtract this 5 on both sides for the first one, so I'll subtract 5 on both sides, I'm going to end up with negative 2x is less than negative 12, and therefore x is greater than 6. That's one solution. On this side, I'm going to subtract the 5 on both sides. That's going to leave me negative 2x is greater than 2. Therefore, x is going to be less than negative 1. And that's my other solution. So keep in mind, this is an OR condition. And when you draw your number line here, your negative 1 sits over here, your 6 sits over here, not inclusive, so they're both parentheses. And I'm drawing them in the correct direction they're going to go in, because x is a number less than negative 1, which is this way, heading to negative infinity. And x is a number greater than 6, which is heading to positive infinity. So this is an OR condition. In interval notation, you would say, in this case, negative infinity, comma, negative 1, union 6, comma, infinity. This would be your interval notation. And set builder notation, you would have a set where x is in a set of values where x is less than negative 1 or x is greater than 6. And that's what that looks like. So I would like for you to try this example here. We're going to solve and graph just like we did above. And whenever we say solve, be careful, because that may mean interval and or set notation, and then graph, obviously, draw the number line. So I'm going to give you 18 less than absolute value of 6 minus 3x. And so go ahead and try to solve this one. Here's your solution for this one. You should end up with negative infinity, comma, negative 4, union 8, comma, positive infinity. Okay, the last example in this textbook is, for this section, is example 11, which is selecting a better deal. So selecting the better deal. And so what they're giving you here, and I'm going to type this up for you because it'll be neater and quicker, I think. So these are good questions for your ACT practice. So in this question, it says Acme Carb Agency charges $4 a day plus, in this case, 0.15 per mile. Remember what I said to you guys, per means that is where the slope sits. Whereas Interstate Rental Agency charges $20 a day and 0.05 per mile. The question is, how many miles must be driven to make the Acme rental a better deal than the interstate rental? So that's your question. And so here you are. Take a moment, write it down as you're taking class notes. So again, this is really good PSAT practice, because one of the things that you need to remember is the word per is indicating right here 15 cents per mile and 0.05 per mile. So we know that as far as Acme, we have $4, which is your y-intercept, and this is your slope, and let's call the miles x. So Acme is basically 4 plus 0.15x. Interstate, and we want Acme to be better than, right? So we're going to go with less than because we want less cost. So we're looking at, in this case, $20 a day and 0.05 a mile. So 20 plus 0.05 x. And so they want Acme to be a better deal. That's why less than, because a better deal for us means spend less money, right? So you have to remember the interpretation part. So if I subtract the 0.05x and bring it over here, this is where I am thus far. So now I have 4 is less than, I'm sorry, I'm mathing very badly today, and that was a joke. So this is actually 4 plus 0.10x is less than 20. And since I moved the 0.05 over, I'm going to subtract that 4. I'm going to subtract this 4 here, and I'm going to subtract this 4 here. And so that leaves me at this point with 0.10x is less than 16. If I divide both sides by 0.10, I'm left with x is less than 160. So it means that in this case, driving fewer than 160 miles, that's the interpretation of the question. Again, you have to go back to the context of the question. So the idea is if you drive less than 160 miles, this is a better deal. So in that case, let's say hypothetically I drive, let's say I drive 150 miles. So let's throw this into the solution. Is 4 plus 0.15 times 150, is that less than the 20 plus 0.05 times 150? Remember, x is a number of miles. So you notice in this case, this becomes 2650 after you do the math, and that is definitely less than 2750. So our solution checks out. All right, and so that was actually a really good question and a really good review for you for PSAT purposes, just FYI. That ends the notes for 1.7.